exercise 2.2, that is of chapter 2, numbers and sequences. Exercise 2.2 is based on the fundamental theorem of arithmetic. Now, what is this theorem stating? It states that every positive integer except the number 1. So, apart from number 1, the other positive numbers can be represented, like it can be written as a multiples of in exactly one way apart from arrangement as a product of one or more primes, which means that every positive number other than 1 can be written as a product of one or more prime numbers. So this is the fundamental theorem of arithmetic. So it is it's explaining the method of prime factorization. So in this whole exercise we are going to do prime factorization. So now the first sum of exercise 2.2 is for what values of natural number. So what is natural number? Natural number, you know, numbers greater than 0 are the natural numbers. So from 1 you will have natural numbers going on. So n is going to be a natural number. So n is a natural number which begins from 1, 2, 3 and it goes on. They are not given till there. 4 power n can end with the digit 6. Now they are asking for what values of 4 power n will end with the number 6. So here when I am taking n is equal to 1. When n is 1, that is 4 power n will become 4 power 1. It is same as 4. So it is not ending with 6. Now when my value of n is 2, that is 4 power n will become 4 power 2. That is 4 square. It means 16. Here you can see that it ends with the number 6. Now again let me see it for 3. When n is 3, 4 power n will become 4 power 3. That is 4 cube. It is 64. Here also you can see that it ends with the number 4 and not with 6. Now let me take when n is equal to 4. That is 4 power 4. 64 into 4, 256. So 4 square, it is ending with 6. And when it is 4 power 4 also, it is ending with 6. So what is the common here? In n is equal to 2 and n is equal to 4. So when n is even number, so I can say when n is even, 4 power n ends with the digit 6. So when n is even, we can find it is ending with the digit 6. So I conclude my statement with 4 power n ends with digit 6 when n is even. In the same way, we have the second question also. If m and n are natural numbers, so m and n are natural numbers, that means the values will be from 1, 2, 3, 4 and so on. Then they are asking for what values of m. They are particularly asked for what values of m does 2 power n into 5 power m end in 5. Now here it is, they have asked when does it end in 5. So we have to take separately for n and m. Now I will take we will substitute the values and see when does the answer end with 5. Now again I am taking when n is 1 and m is 2. So 2 power n into 5 power m, that means 2 power 1 and 5 power 2. 2 into 5 square is 25, it will be 50. Again, I can see that when n is 1 and m is 1, it is ending in, not ending in 5. Now, let me take in this way. When n is 2, and m is 1, then 2 power n into 5 power m. So 2 square into 5 power 1. 4 into 5. That will be 20. Again, it is not ending in 5. So let me see in this way. When n is 2 and m is 2. So 2 power 2 into 5 power 2. That is 2 square is 2 power n into 5 power m. 2 square into 5 square. 4 into 25. That is also 100. So here when I take n to be as an odd number and when I take m also as odd number, when both n and m are also odd numbers or alternatively odd and even, then also my answer doesn't end with 5. The same way when I take n to be even, the other m value to be odd or both to be even numbers, even then also my answer does not end with 5. So we can say that for no values does 2 power n into 5 power m ends in 5. Find the HCF of 252525 and 363636. So this is our third sum. Now here in this sum we can see that find the HCF. Immediately we get reminded of the Euclidean division lemma. But since they have not mentioned the method of solving it, so we will do it in a normal way of solving, that is finding the factors like prime factorization method. So we will factorize the number 25252. So number ending in 5 is divisible by 5. 5 5s are 25. 0 5 0 5. Again we are dividing this by 5. 1 0 1 0 1. So this 10101 is a prime number which can only be divided by 1. So finally 10101. So writing the factors of 252525, we have 5 square into 10101. The same way we can factorize 36636 when we factorize it by 2. 18 ones are 8 ones are 8. Again we can do this by 2 tables. 2 nines are 18. 0 9 0 9. Number ending in 9. So 3 3 0 3 0 3. Again we are dividing it by 3. 1 0 1 0 1. use 2. So 2 square into how many 3? 3 square into 10101. Now how do you find the HCF of two numbers using this method? It's just by seeing the common factors between the two numbers. So what are the common factors here? You have here 5 but you do not have here 5. 2 and 3 are here. It is not there. So the only common factor is 10101. So that is going to be my HCF. So in HCF of 2525 and 363636 is 10101. Now we have the fourth sum. If 13,824 is equal to 2 power a into 3 power b, then find a and b. So they have written 13,824 in multiples of 2 and 3, but in how many multiples? So how many? What is the power of 2 and 3? So that we have to find. So we will do it using prime factorization method. So 1, 3, 8 to 4. So what is the first step? We have to divide this by the prime numbers. So you know what are the prime numbers? They are 2, 3, 5, 7, 11. So numbers which are divisible by except for 1, that is the prime number, and 1 is not a prime number. So the prime numbers are starting from 2, 3, 5, 7, 11, 13, 17 like that. So it will be divisible only by itself or 1. So 13,824 we are going to divide it by 2, the first prime number. So seeing the last number, we will do the prime factorization, by which number it will be divisible. So 4 is divisible by 2. So using that we are going to divide it. So 2 6 are 12, 1 9 18, 1 2. Again you have it ending in an even number. So dividing it by 2, 3s are 6, 2 4s are 8, 1 remaining, 5, 10, then 6. Again you divide it by 2, 2 1s are 2, remaining 1, 14, 2 2s are 4, then 8. 2 8s are 16, 1 remaining, 2 6s are 12, 2 4s are 8. Then again you divide this number by 2, 2 4s are 8, 2 3s are 6, 2 2s are 4. Then 2 2s are 4, 2 1s are 2, 1 is the remaining, then 2 6s are 12. Again you divide it by 2, 2 1s are 2, you have 1, it is not divisible, so you put 8, then 16, it becomes 2 8s are 16, then 2 5s are 10, 2 4s are 8, so 2 27s are. Again this 27 we know it is divisible by 3, and 3 is also a prime number. 3 9s are 27, 3 3s are 9, and 3 finally it goes in one table. So now you can see that we have divided 13,824. We are factorizing using prime factorization. So how many 2's are there? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 2's. So finally I can write 13,824 in terms of 2. That is, we have 9 2's. So we write it as 2 power 9, and how many 3? 1, 2 and 3. So there are 3. So in the place of A you have 9, and in the place of B we have 3. The power of 2 is 9 and the power of 3 is 3. So that is what we have to find out. The fifth sum is also the same as like fourth sum, but we have here certain conditions. If P1 to the power of x1 and P2 to the power of x2, P3 to the power of x3, P4 to the power of x4 is equal to 113400, that is 1,13,400. Then where P1, P2, P3, P4 are primes. So all these are prime numbers in ascending order. So that is a very important thing. We have to see they have to be written in ascending order. The factors of this number we have to write it in ascending order. And x1, x2, x3, x4 are integers. So they are all integers. Now find the values of P1, P2, P3, P4 and x1, x2, x3 and x4. The same way we have to do prime factorization, that is dividing this number using the prime numbers. So we can write the factors. Through prime factorization. So starting prime number 2 5s are 10, 2 6s are 12, 2 7s are 14. Then we have the 2 zeros, 2 2s are 4, 1 remaining, 2 8s are 16. Then 2 3s are 6, 1 remaining, 2 5s are 10, 0. 2 1s are 2, 2 4s are 8, again 2 1s are 2, then 1 remaining, 2 7s are 14, you have one more 1 remaining, then 2 5s are 10. So now you have the number ending with 5, any number ending with 5, it is divisible by 5. So now you divide the number by 5 because 5 is also a prime number. 5 2s are 10, 4 remaining, 5 8s are 40, you have 1 remaining, then 5 3s are 15 and 5 5s are 25. Again you divide that by 5, 5 5s are 25, 3 remaining, 5 6s are 30, 3 remaining, then 5 7s are 35. Now you have the number ending with 7. Now let's see in 3 tables. So 3 1s are 3, then 2 remaining, 3 8s are 24. Again you have 2 remaining, 3 9s are 27. So it's again divided by 3, 3 6s are 18, 3 3s are 9, 3 2s are 6, 3 1s are 3, 3 7s are 21. So finally we have come to the prime number and 7 is divisible by 7 1s are. So now we have factorized this number. And now let's write the multiples and see how they have asked to write the factors. That is P1, P2, P3 and P4 in ascending order. Now first let us write 1, 1, 3, 4, 0, is equal to, first let us write the factors here. 2 we have, 3, 5, 7. So in ascending order we have written the factors. Then how many 2's are there? 1, 2, 3. So 2 power 3. How many 3's are there? 1, 2, 3, 4. 3 power 4. How many 5's are there? 1, 2 and 1, 7. So there are 2 5's and 1 7. Now when comparing with what they have given, we can write the values of P1 is 2, P2 5 is 2. The power of 7 is 1. The sixth sum, find the LCM and HCF of 408 and 170 by applying the fundamental theorem of arithmetic. So that is what we have to find the factors and then find the LCM and HCF. Here they have mentioned using which method we have to find the LCM and HCF. So let's just first factorize and find the factors of 408 and 170. So 408 and factorizing it first by 2, dividing it by 2, 0, 4, then again by 2, 1, 0, 2, again by 2, 5s are 10, 1. Now by dividing it by 3, 3 ones are 3, then 7. 17 3s are 51. So 17, we know it is a prime number which is divisible by itself. So 17 ones are 17. So I can write the factors of 408 are 2 into 3 into 17. And how many 2s are here? 3. That is 2 cube, 3 power 1 and 17 power 1. The same way let us do the prime factorization for 170. Dividing it by 2, 2 8s are 16. Remaining 1, 2 5s are 10. You have 85, so I divide it by 5. 5 ones are 5, remaining 3. Then 5 sevens are 35. Same way 17 is divisible by 17. The factors of 170 are 2 into 5 into 17. So 2 power 1, 5 power 1 and 17 power 1. Now they are asked to find the LCM and HCF. Now how do you find this LCM and HCF? So let us find now the LCM. So for finding the LCM, we take down all the factors that is there. 2, 3, 17. Again you have 2, so you should not take it again. Once you have taken the factor, it is taken once. So 2, 3, 17 from 408 and from 170, 5. So you don't have 5 here, write 5. Again you have 70 which should not be written again. So now see the powers, compare the powers. So when it is LCM, least common multiple, the powers you have to take is the highest power. So the factors which has the highest power. Since I have 2 repeated here, I will see which factor has the highest power. So it is 2 cube. I will write here 2 cube. Now 3 power 1, only 3 power 1, 17 power 1, it is only 17 power 1 and 5 power 1, only 5 power 1. Now for HCF it is completely different. For HCF you have to take the factors which are common. So which are the factors which are common in both? You have 17. So I'll write 2 into 17. And now the powers. You will take the least power of the repeated factor. So which is repeated factor 2? Which is the least power over here? 2 power 1. So 2 power 1. 17 of course it's same there both. 17 power 1. Now let's solve this. Because we have to find the LCM. So 2 cube is 8. 8 into 17 into 15. The same way over here. 2 into 17 it is 34. Into 15 it is 2040. Now 2 into 17 the HCF is 34. So in one method we have found out both the LCM and the HCF. The seventh sum, find the greatest number consisting of 6 digits. So greatest number and it is a 6-digit number which is exactly divisible by, again you have divisible by 24, 15, 36. So 36 will surely divide the greatest 6-digit number. So we will find the factors of 24, 15 and 36. So by finding the LCM, that is the common multiple, least common multiple, that number would surely divide the greatest 6-digit number. So we are going to not separately find the greatest number. Instead of doing that long step, we are just going to shortly do the sum by finding the LCM. So 2. We are going to divide 24 by 2, 2 12s are, 2 6s are, 2 3s are, then 3 1s are. 15 by 3, 3 5s are, 5 1s are. Then 36, we divide it by 2, 18s are, 2 9s are, 3 3s are, and then finally 3 1s are. So let us write the factors. 224 is equal to 2 into 3. How many 2's? 1, 2 and 3. So 2 cube into 3. For 15, it is 3 into 5. For 36, you have 2 into 3. How many 2's? 2 square and 3 square. So LCM is LCM is 2. Let's first write the factors. Into 3. Again you have 3. So into 5 and finally into 2 into 3. So as I told you in the previous sum, for writing the LCM, the power should be of maximum. The highest power should be taken. So for 2, which is the highest power? Cube. For 3, it is 2. And for 5, it is 1. So 2 cube, 8 into 9, 3 square is 9 into 5. So when you multiply, you will get 360. So this is the LCM of 24, 15 and 36. When you have LCM of 24, 15, 36 is 360. Now we are going to find the greatest 6-digit number, which is going to be divisible by 360. So in that, using this, we are going to find the greatest 6-digit number. So we now found out the LCM of 24, 15 and 36. To find easily the greatest 6-digit number, which is going to be divisible. So now we all know the greatest 6-digit number. 6-digit number is 99999. So this is the greatest 6-digit number. So now I am going to divide this by the LCM 360. So 360. 9 divided by 360. So 2's are 720. When I subtract, I get 279. I bring this 9 down. Again, 7's are, let's say we will multiply 360 into 7. 2520. The remainder will be again 279. You bring down the next 9. 2520. Again you have the remainder 279 and you bring the last 9 down. Again it will be divisible by 7 tables. So 360 into 7, 2520. The remainder will be 279. So when we divided the greatest 6-digit number by the LCM 360, we got got a remainder. So to find the greatest six-digit number divisible six-digit number divisible by 24, 15, 36. So for that we have divided the greatest six-digit number by the LCM. So we got the answer as 999 minus the remainder. Now why am I subtracting the remainder is that because we need to find the six-digit number divisible by these three numbers. So when you subtract the number, you will get the answer which will be divided by these three numbers. So what will be the answer? 999,720. So this is the greatest six-digit number which is divisible by the 24, 15 and 36. Now let's see the eighth sum. What is the smallest number that when divided by three numbers 35, 56 and 91 leaves a remainder 7 in each case. So there is a smallest number and that smallest number we are dividing it by 35. We are also dividing it by 56 and even by 91. When we divide by these numbers, we get the remainder 7. Then what is that number? So to find the smallest number, so what we are going to do? We are going to find the LCM of 35, 56 and 91. Just like the previous sum, let us do the prime factorization. So 5 sevens are 35, then 7 ones are 7. The factors of 35 are 5 into 7. The same way for 56, 2 28s are, then 2 14s are, 2 7s are, then 7 ones are. Factors of 56 are 2 cube. We have 3 2s into 7. The last one is 91 divided by 7. 7 ones are 7. You have remainder 2. Then 7 3s are. 13 is a prime number, so it is divisible by 13. Ones are 13. So 91 is equal to 7 into 13. Now how do you write the LCM? We have to take all the factors that are there. So 5 into 7 into 2. Again 7 is there which we have already written. Again 7 is coming. Then we have 13. For the powers, as I told you earlier, take the maximum, that is the highest power. So for 2, we will write 8. So 5 sevens are 35, 2 cube, 8 into 13. The LCM is 3640. Now what have they said? They have said it leaves a remainder 7. So we know LCM is 3640 and now they have asked to find the smallest number. So to find the smallest number divisible by 35, 56, 91 and it leaves a remainder. How much is the remainder? 7. So it is very simple. To the LCM, we will add this remainder. So the smallest number is 3647. Now the last sum of this exercise 2.2. Find the least number. So least number itself means we have to find the LCM. That divisible by first 10 natural numbers. So what are the first 10 natural? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the natural numbers. So we have to find the LCM of these natural numbers. So we write the factors. So 1, 2 power 1, 3 power 1, 4 is 2 square, 5 is 5 power 1, 6, 2 into 3, 7, 7 power 1, 8 is 2 cube, 9 is 3 square, and 10 we can write as 2 into 5. Now to find the LCM, as I told you, we'll write down all the factors. So 2, 3, 1 we did not take. So 2, 3, again you have to, then 5, again 2 and 3, then 7, again 2, 3, already have written, and 2 and 5 was already written. Now, as I told you earlier, for the powers of LCM, how you should take? We have to take the highest power. So for 2, check which is the highest power here. It is 2 power 3. So I will write cube over here. And for 3, it is 3 power 2. So 3 square. And for 5, it is 1. And 7 also it is 1. Now let us solve this. 2 cube is 8. 3 square is 9. Then 5 sevens are 35. 8 nines are 72. Into 35, the answer you get is 2520. So this is the LCM, and this is the least number divisible by first 10 natural numbers. So the number which is divisible by the first 10 natural numbers is 2520.